Hello everyone. In this video, I'm going to show you how you can use Langchain to add memory to your chatbot. So the chatbot has a previous conversation history that it can draw from when answer new questions. First, I'm going to show you how you can add memory to your chatbot when the user interact with the chatbot, and later on we are going to expand that to the retrieval-augmented generation so that the user can have a continuous conversation with a vector database, for example, a PDF file. Okay, so let's get started. I adopt most of this content from the Learning Langchain, which is a new book in O'Reilly Media. If you are interested in purchasing that book, the digital pre-printed version is available, and it's an excellent book, and I highly encourage you to purchase that. Okay, so here first we import a number of modules, mainly from the Langchain. Um, and we first create a prompt template. We provide a system message. You are a helpful assistant. Answer all questions to the best of your ability. And then in the placeholder, I provide a space where the previous conversation history, basically the messages, back and forth between the chatbot, the language model, and the user can be stored. And then I obtain a chat model, and then I chain the prompt template with the large language model, and then we can evoke the chain. No, you can use chain invoke and then provide a user input. But here I pre-populated a few messages, separated between human message, say, what's your name? AI, my name is John, and human, sorry, what is the name again? So this is just to illustrate that when uh, the uh, uh, the chat include the previous messages, between human and AI. Then when the human asks your name again, it has the previous memory. So the AI should answer, no, my name is John, rather than I'm an AI assistant. Okay, so let's take a look at this. Indeed, the AI answer, no problem, my name is John. It means that when the human poses a new question, because the system has uh, the previous messages stored in this prompt template, so therefore the AI can reply with the context of the previous conversation. However, no, in reality, we can't really add the messages manually one by one to the prompt template. But fortunately, the Langchain provided us with this in-memory chat message history. So this actually is going to create a dictionary that we can store our previous messages. Okay, so let's initiate this chat history. And then now we can add user message and AI message to the chat history. So for example, here I add a user message, what is your name? And then I add an AI message also to the chat history. My name is John. And then you can print out the history using the chat history dot messages. So this should make sure that now the two previous messages have been stored in the chat history. So let's do that. You see here we have a human message content, what's your name, and the AI message content, my name's John. Okay. And then we can integrate the stored chat messages into our chain and send a final prompt to the model. So for example, here, the response would be chain. We invoke the message we provide the messages, the chat history messages, um, to the previous chain. And in this case, if we ask this question, sorry, what is his name again? Um, then the chat would be able to pick that up and then answer it based on the chat history. So let's try this. And indeed, the model answered, "My name is John." So that is because we provide the chat history to the model. So the model have a history on file, and therefore it will be able to answer this question. Okay. Okay. Uh, so that is a simple demonstration of the capacity of allowing the chain to have memory by utilizing the in-memory chat message history. Okay. Uh, However, although we can integrate the chat message into the chain explicitly, but usually in the production setting, we need a way to persist chat history and automate the insertion and updating of it. So, to solve that problem, we will utilize the Langchain's runnable with matches history class to automatically insert and update chat messages. Okay, so let's take a look at that example. Um, the first step is to modify our prompt template to incorporate a chat history parameter, which will later contain all prior chat messages. Okay. So here we provide this new prompt template. We have a system message. You are a helpful assistant. Answer all questions to the best of your ability. And then notice that besides the human input, we also have a so-called placeholder in which we host the chat history. Right? So later on, we are going to populate the history with the chat history using the runnable with message history class. Okay. But first, let's complete this chain. The chain is just a prompt template, and then send that to the large language model. Okay. But now that's built on the history class. Okay. So to build the history class, we first still use the in-memory chat message history, okay, to create that instance. And then we are going to wrap that chat history for chain around using the runnable with a message history class. Okay. So the way to do that is to call runnable with message history. And inside, we need to provide four things. Okay. The first thing is the chain itself. Okay. And the second thing is the in-memory chat message history. So it is this object. And this object is session specific, meaning that we need to provide a session ID. So the session ID is identifier for the session, or we say the conversation thread that the input messages correspond to. So in this case, the chat history for chain is going to be session specific. So if you provide a different section ID, you can store a different chat history for that specific section ID. So in this case, the runnable with message history extend beyond the chat history for chain because now you can use it to maintain several conversations or threads with the same chain at the same time. Okay. So therefore, in simple applications, you can just use the in-memory chat message history, but the limitation would be it can only store everything in that single history. It can't really differentiate between different threads of conversation. Whereas if you use runnable with message history, is going to create a dictionary in which each key is a distinct section ID, and value corresponding value would be the chat history. Okay, so that is the advantage of using runnable with message history in comparison to in-memory chat message history. Okay. And the third thing you need to provide to the runnable with message history is the input messages key. Okay, and that key, it should correspond to the human here in the prompt template. Basically, you should call the same name as input, because the input would be the user input. Okay, um, and finally, the fourth and the last thing you need to provide to the runnable with message history is the history message key. And that should correspond to the history, which is called in the prompt template. Okay. Okay, so that is going to complete the runnable with message history class. Okay, so that's initiate that class. And now you are ready to create the entire chain. Okay, so let's take a look of the full example from the beginning. So first, you create the prompt template as we previously did. We create a system message, we provide the placeholder, which is going to store the history, and then we need to provide the human input. Right? Then we can call the large language model and initiate that chain. And then you are going to create a history, and that it's called histories. So the history is going to be a dictionary. Okay, so first it's going to be empty dictionary, and later on is going to have session ID as the key, and in-memory chat message history as the value. Okay, so but you can initiate the histories as an empty string. So this part is optional. So this is called the type hinting. The type hinting is only available in Python 3.9 and forward. Basically, this is a way you can imply that history is a dictionary, and the dictionary is going to to take strings because the strings are the session IDs, and then the values would be the in-memory chat message history. Okay, so this part is just an indication what should be included in the histories dictionary. Okay. Okay, now we can start building the function that can take a section ID as an argument and then returns a chat history object. Okay, so the function is very simple. We call it get section history. So the input should be a section ID, and it should be a string variable. Again, this part is the type hinting, which is only available in Python 3.9 forward, indicating section ID should be a string variable, and the default is an empty string. Okay, so if the section ID is not in the dictionaries of histories, basically if section ID is not a key in the dictionaries, and then you just add that new section ID to the dictionary with the corresponding chat history as the value. Okay, and then you return the dictionary with that specific section ID as the key. Okay, so basically what you return is the conversation pertaining to that specific section ID. Okay. And then, of course, you follow the same runnable with message history class to build that class. It asks for the chain, and now you get a function to take a section ID as the argument and return the corresponding chat history object. And then you have the input message key equals input, because that is implied in the prompt template, and then the history message key as history, which is also implied in the prompt template. Okay, so after we run this, now we can test it out, okay, to see whether this new chain with history works. The chain is named with message history. Okay, so now first let's invoke it with an input, a human input. Hi, I am Bob. And in the configuration dictionary, you provide the configurable and in which you can provide your section ID. Okay, so now that's aimed at section ID 123. You could think of this as a specific thread pertaining to that particular individual. Okay, so if you implement that, then the corresponding AI message is, "Hello, Bob. How can I assist you today?" Right? And now let's keep the conversation. Still, have the conversation within the same section ID. It's still section 3, ID 123, but this time you ask, "What is my name?" Okay. So in this case, if the with message history chain is successfully implemented, then you should recall that my name is Bob, right? Because that is what I told the chatbot in the first place. Okay, so let's try this out. Then indeed, it mentioned that your name is Bob. How can I assist you further today, Bob? Okay, so it means that the with message history does remember the previous conversation. Okay, however, no, now let's try a new section ID. Okay, so in the new section ID 456, I asked the same question, what's my name? But in this case, because it starts a new thread of conversation, and it has no previous conversation stored for the section ID 456. So therefore, the chain, the with message history, should not know what my name was because we have not started that conversation. So therefore, if you initiate that chain, you get an answer, "I'm sorry, but I don't have access to that information. How can I assist you today?" Okay. So hopefully that demonstrates how the with message chain works. You can also optionally print the entire dictionary. So you can take a look of the previous conversation for section ID 123. The first conversation is, "Hi, I am Bob." The second is from AI message, "Hello, Bob. How can I assist us today?" And uh, and corresponding and other informations here. And then there's another human message, "What's my name?" And then AI message, "Your name is Bob. How can I assist you further today, Bob?" Right? But for 456, it only have one back and forth conversation, right, between the AI and the human being. The human being asks, "What's my name?" And the AI asks, "I'm sorry, but I don't have access to the information. How can I assist you today?" Okay. Okay, so that is how you can recover the conversation history per thread. Okay, so in many cases, the chat history messages aren't in the best state or format to generate an accurate response from the model. Uh, there are various reasons. One is the model size is limited. The window size is limited. It can't take if the conversation is too long. And the second, no, a lot of conversations are not really relevant, and adding those irrelevant information is going to increase the risk of hallucination for large language models. So to overcome the problem, we can modify the chat history in a variety of ways. Okay. The first way, the simplest way probably is to trimming the message. So we know that LLM have limited context windows. So therefore, the final prompt sent to the model can exceed the model's input token limits. And for many models, it has a limit of, say, 4,096 or 8,192, right? So excessive prompt information can distract the model and lead to hallucination. And therefore, we can trim the conversation and uh, uh, and one way to trim it is to use this convenient trim underscore messages provided by Langchain. It's very self-explanatory. You can set the maximum tokens you want to store in the trimmed message. You can specify whether you want to trim from the last message or from the first. Strategy equals last means that you're going to maintain the last messages, but remove the previous messages. Okay, and you can specify, in which model you are going to count for the tokens. Okay, I'm going to use the GPT-4o model to count the tokens. And the include system equals true means whether you want to include the system message, regardless how you trim other messages. And allow partial equals false means you do not allow partial message. You don't want to trim no part of the sentence, say. And start on equals human, will ensure that we never remove an AI message that is a response from the model without also removing the corresponding human message, which is the question for that response. Okay, so we initiate the trimmer. And now let's take a look how the trimmer works. We create a long message. So it's a combination of system message, human message, and AI message. And it's pretty lengthy. So when we use the trimmer, when we invoke the trimmer, and then we will take a look, now the system message is maintained, but then some of the messages, previous messages were lost. And basically, I think we start from here all the way to the end. Okay, so that's probably count for a total of less than 65 tokens. Okay. Okay. So now let's incorporate the trimmer into a chain and random with message history. So to use it in the chain, we need to ensure that the trimmer is run before the message is input to our prompt. Okay. So let's follow this example. We have a prompt template, and we have a system message. You are helpful assistant. Answer all questions to the best of your capacity. And we have a placeholder as previously to hold the chat history. And then we get a large language model. In this chain, it makes a messages key available to the prompt template. Okay, after passing the input message list through the trimmer. So it's going to be a dictionary with the messages as the key and trimmer as the value, and then chain that to the prompt template and further chain that to the LLM. Okay. So that the trimmer is going to trim the previous messages and then send the trimmed messages to the messages in the prompt template, and then move on to the large language model for generation. Okay. So here to track the history, because this is a simple user case and we don't have multiple threads, so I can just use the in-memory chat message history to save the content, the chat history. Okay, and oh, I'm sorry. Actually, we does still use the runnable with message history. But actually, you could if you don't need to differentiate the different threads, you could just use the history here. But we did use the runnable with message history class. Okay, so we provide the chain, and also we provide the history. Okay, but here the history is simple because we actually don't differentiate different sections. Okay, so in this case, it basically stored every chat history in that same in that same history object, but doesn't create different section IDs for different threads of conversation. Okay. Okay. So that is the implementation. and then let's try to use it. Here you can invoke invoke the with match history, the newly created chain, with today is a good day to learn about Langchain. Do you agree? Okay. And then in the second node, where we invoke why the sky is blue, the third one is what's the capital of France, and then the next one, tell me a joke, and then finally, what joke did you tell me? Could you repeat it? Okay. So in this case, I want to test whether it still has a memory of the last tell me a joke, right? So if they remember, then it's going to tell me that joke again. Okay. So let's implement this. It's going to take a while because the model is going to evoke one by one and then to store all the conversation, but then it's going to trim the conversation chat history to only the last 65 tokens. Okay, so here the last message. AI message in response to the question, what joke did you tell me? Could you repeat it? It mentions, certainly, here is the joke again. Why couldn't the bicycle stand up by itself? Because it was too tired. Okay, so that is good. Um, and you can also print the history of the conversation. If you print that history of the conversation here, so you would have the in-memory message all the way to the jokes it talk about. Okay. Uh, where is here? Right here is about the joke. Okay. So that is how you do the trimmed history. Although the history still is complete, but the way when we feed the history into the with message history chain is that we trimmed it. We only include the last 65 tokens. Okay. Okay. But trimming the memory is not the only way that we can deal with the window size problem. The second way we can deal with that is to use the summary memory. Okay, so basically we do a summarization of the previous chat history to make it brief. Okay, so that is demonstrate how we can use the summary memory. Okay. Uh, so here, no, first we create a instance for the chat message history. Okay, so there's a slight difference between chat message history and the in-memory chat message history. So the chat message history serve as a base class for managing chat histories with potential for various storage implementations, whereas the in-memory chat history is a concrete subclass that handles storage in memory, okay, in real time, okay, when the program runs, okay. So here I initiate a chat message history class, okay, instance, and I stored it in the demo uh, ephemeral chat history. And then I add some user message, hey there, I'm Nemo. I add an AI message, hello. I add further a user message, how are you today? I add a further AI message, fine, thanks. Okay, so I add those messages to this demo chat history, and you can take a look that it has been stored in that messages as human message, AI message, again human message, and again AI message. Okay. Um, and now we can create a prompt template. And this template is the system message is you are a helpful assistant. Answer all questions to the best of your ability. The provided chat history include facts about the user you are speaking with. Okay. Uh, So basically, it asks the, uh, the system to look at the chat history, right? And then in the messages placeholder, you specify the variable name equals chat history so that the chat history will be saved um, and be able to be retrieved. Okay? And then finally, you provide the user input. Okay. Okay, so now we can chain the prompt to the LLM as we previously did. And then we can create the chain with message history, still using the runnable with message history class. We initiate a class with the chain we built. And this time, remember when we use Lambda session ID, we are going to save the history by session ID. Okay, so that we can manage multiple threads of conversation at the same time. And the user message key will still be input. The history message key will be just chat history. Um, okay, so that's not surprising. That is exactly what we've done previously. But the new function here we are going to build is a summarization function. We call it summarize messages. So we create this function which will distill previous interactions into a summary. And remember, we need to add this to the front of the chain. Okay, so that is going to summarize the chat history before feeding into the chain. Okay. And how we do that? Well, this is a simple function. So first, we get the stored messages. The stored messages are from this chat history. Okay. And then we first check whether there is any stored messages. So if there's none, then we just return false. Okay, so we don't even bother look at it. Okay, because there's no history, so there's nothing to summarize. Okay, but if no, the length is not none, then we create another prompt. We call it a summarization prompt, which will be used to call the language model and to summarize the chat messages. Okay, so in the prompt, we still have a message placeholder. No, we need to grab that chat history, and then the user message would be distill the above chat message into a single summary message, include as many specific details as you can. Okay, so in this case, we are not hopefully losing important information from the chat history. Okay. So we create this summarization prompt and we chain it with the large language model. Okay. So therefore, this chain is going to look for the chat history, summarize it, and then feed that into the large language model. Okay. To get it summarized. Okay. And then we need to invoke the summarization chain. We provide the chat history. The chat history will be just the stored messages. Um, and then after that, we clear the chat history. So this is important because then we have when we summarize the message, we don't need to keep track of the chat history, um, because otherwise we have to when we do the summarization again, we include all the previous messages. Okay, so that won't be good. So therefore, no, after the summarization, we are going to remove clear the history. Okay. Sorry, my browser just restarted, so we need to run the previous uh, the the previous cells again. Um, and after that, we add the summary message into the chat history. Okay. So that is about this summarized messages, and then we return true. Uh, so that is the summarize message function. And then finally, we add that function to the chain with the message history. We use runnable pass through, assign, and we assign this summarize messages. And then so this uh, the pass through just means that when this is true, uh, then we should do the summarize message, but when it returns false, it's just going to ignore this. Okay, and then we chain that with the chain with message history. Okay, so in this case, the message is going to be summarized and saved into the chat history, and then feed that history, into the prompt, and then run that with the large language model. Okay, so that is the idea. So let me rerun all the previous code so that we can now invoke the chain to see if they remember the chat history. Okay, so to invoke the chain with summarization, the input will be what did I say my name was? Um, so because previously I told the uh, I told the chain that in the chat history that hey there, I am Nemo, right? So the model should remember that if it has persistent memory. Okay. Um, then we don't use the section ID, so the section ID is unused. Okay. So let's try this. Chain with summary. Oh, we forgot to run this. Okay. And let's run this again. And indeed, you get this AI message. You introduce yourself as Nemo. Okay, so in this case, the summarization chat history works, and the model has a memory. So it recall that my name is Nemo. Okay. So besides the trimming and summarization, you can also filter messages because as the list of the chat history message grows, a wider variety of types, subchains, and models may be utilized, and Langchain provide a filter underscore messages that makes it easier to filter the chat history message by type, ID, or name. So let's briefly demonstrate that. You have no messages, no, you have the system message, you are a good assistant with the ID of 1, you have a human message, example input with ID of 2 and name of example user, you have an AI message, example output with ID of 3 and name example assistant, and you have a human message, real input with ID of 4 and name of Bob, and finally you have an AI message, real output, ID of 5, name of Alice. Okay. So now you can use the filter messages function to ask for two arguments. First is the message itself, and the second is whether you want to include or exclude anything. Okay, so here I want to include the type human. So it's only going to include the human messages. As you see here, only two human messages are filtered in. You can also use exclude names to exclude certain names. I'm going to exclude example user, example assistant. So in this case, there are no example names of example user or nor example assistant. You can also use both include and exclude. So now I'm going to include type of human message and AI message, but I'm going to exclude IDs of 3. Okay, so definitely you can do that. Okay. And finally, you can exclude names. Okay. And then after you build this filter, you can chain that with an LLM. Okay, so that the chain is only going to include the messages that are without the name of example user or no example assistant. Okay, so this is one way you can use the filter, okay, to filter out certain chat history. Okay. And then finally, let's demonstrate how you can use the chat history with retrieval. So previously, when we introduced the RAG system, a variety of RAG, retrieval-augmented generation system, you can chat with your vector database that you build from your TXT file or PDF file, but the conversation history is not saved, so that no, when you ask a question about a PDF file and ask another question, then those two questions are independent. The second question doesn't have the history of the first question asked. Okay. So, for example, if you ask the first question, who is the president of the United States, and then you ask, who was that? Then the second conversation will not go anywhere because it doesn't have the memory of the first question you ask about the president of the United States. Okay. So that's demonstrate how now you can build chat history with RAG system. Okay. So here you should be quite familiar with. This is the boilerplate code we used to load a document, load a TXT file. It's a simple TXT file teaching with generative AI. This file, and then you load it, and then you create a text splitter to split the document into chunks, and then you define an embedding model, and then you provide the chunks as well as the embedding model to the FAISS local vector database to create a vector store to save the embedded chunks. And finally, you create a retriever from the vector database so that now the retriever will be able to identify queries that are similar to the data stored in the vector database and return those documents. Okay, so let's implement that. And now next we need to define a subchain that takes historical chat messages and the latest user question, and then reformulate the question if it makes reference to any information in the historical information. We'll then use the subchain inside the final RAG chain, which will basically follow the following three procedures. The first procedure is to rephrase the user's question given the conversation history. Of course, given there is history, otherwise it just use the original user's question. And then you pass the rephrased question to the retriever to get the most relevant documents. And third, you pass the original question, the chat history, as well as the retrieved documents to the final prompt to generate an answer. Okay, so it follows three steps. Okay, we've already built the retriever, and now let's work on this. Rephrase the user question given the conversation history. Okay, so first we define a function to extract the content of a message. Okay, so if the message we need to retrieve the content will be just the chat history. And then we define a system prompt for contextualizing the chat history to come up with a standalone question, because that standalone question later on is going to be used by the retriever to retrieve documents. Okay, so that's that system prompt. We call it contextualized system prompt. Is that give a chat history and the latest user question, which might reference context in the chat history, formulate a standalone question which can be understood without the chat history. Do not answer the question, just reformulate it if needed, and otherwise return it as is. Okay. And then we can define the prompt for contextualizing the chat history to come up with a standalone question. And in that prompt, we first refer to the system prompt the contextualized system prompt. And then the placeholder would be the chat history, and then the human input. Okay. And now we can define the chain for contextualizing the chat history to come up with a standalone question. We call it contextualized chain. It calls for contextualized prompt, and then link that to a large language model, and then retrieve the message from that model. Okay. Uh, okay. So that is the first chain, contextualized chain. And now let's build the second part, which is that we pass the rephrase question to the retriever uh, uh, to uh, so that is where is that? Uh, is here to define the question answering system prompt to generate the final answer. Okay, so that will be actually the third step. And finally, we are going to work the second step by linking to the retriever. Okay, so that chain is going to pass the original question, chat history, and documents to the final prompt to generate an answer. Okay, so to do that, we first define the question answer system prompt to generate the final answer. Okay. And we call the QA system prompt. It says you are an assistant for question answering tasks. Using the following piece of retrieve the context to answer the question. If you don't know the answer, say that you don't know. Use 3 sentences maximum and keep the answer concise. And then no, you are going to get the context, which is just a retrieve the documents. Okay. Then you can build the question answer prompt using the system prompt. So you basically call out the system prompt here. And then the placeholder would be the chat history, and then provide the human input, and then you can chain them together. We call it the QA chain. It is a chain to generate the final answer. Okay, so you link the QA prompt with the language model, and again you get the content of the output of the message. Okay. Okay, and finally, let's chain these two together. These two contextualized chain and also the QA chain together. Okay, by using the retriever that we built previously. Okay, so we built that chain using the decorator chain. Okay, so it can be invoked, and we call the history aware QA. And in that chain, the only input is the user input. Okay, and first we apply the input. The input go through um, the contextualized chain to be rephrased, but only if the chat history is available. Okay, so if the input if there's no chat history, then there's nothing to be contextualized. Okay, so therefore we don't need to rephrase the input. Okay, so so this if else statement take care of that. There is chat history, then go through the contextualized chain so that it can rephrase the input based on the chat history. Otherwise, no, just the question would be just the original input. Okay. And then you can get the context from the retriever by invoke the retriever chain. Okay, so that is going to get all the retrieved documents from the vector database. And then finally, you get the final answer by invoking the QA chain. Okay, and the QA chain asks for the input as well as the context, and the context will be just retrieve the documents. Okay, so that's initiate all the 3 chains. Okay. random sequence object is not callable. So that is possibly because maybe I forgot initiate here. Did I miss something? So let's do this again. Okay, now it works. And then finally, we need to provide the chat history, right? Remember that we can, as previously, we create an in-memory chat a message history object, and then we wrap it around with the runnable with message history, in which now I provide this entire chain. It's called history aware QA, and then I use the lambda function to store the chat history for chain. So there's going to be section specific chat history, and then I provide the input and chat history as previously. Okay, so that's incorporate the stateful management of chat history. And finally, we can evoke the chain. Okay, so the chain, we ask the first question, should faculty declare the AI policy in their classes? And remember, the answer to this question is indeed included in this teaching with generative AI TXT file that we used to build the retriever. Okay. So if we initiate that, it's going to give us an answer because this time it's not going to revise the input at all because the system doesn't have the previous chat history. So therefore, the answer is yes, faculty should declare the AI policy in their classes to help students understand what is and is not allowed regarding AI use. Okay. But now let's test out this with a follow-up question to see whether we have persistent memory. In this case, the input is, what question did I just ask? Okay. Notice that I used the section ID 1 to 3 for both. So therefore, the chat history for section ID 1 to 3 should be stored, and then the information, the chat history should be used to reformat, to reformulate the input question. Okay, so the input question should be pretty similar to this original input question. Okay, so let's try this. And then indeed, it returned this is you ask whether faculty should declare the AI policy in their classes. Okay, so in this case, the system does have persistent memory as we anticipated. Okay, so that's how you can use, you can build memory, into your RAG pipeline. Thank you for watching, and I'll see you next time.